All right, welcome to the Unit 4 Summative Assessment Study Guide. We are going to jump right in. Make sure that you have your name. I'm DJ Tay. Woo woo. Today's date may not be when you see it. And the class period I'm going to represent today is my 7th period. All right, so number 1 says Everett made 10 bracelets on Saturday. Write an equation to show how many more bracelets he will need to finish making 38 bracelets. All right, so we already know that we're going to use the variable B for bracelets. All right, and he already made 10. So 10 plus however many more bracelets he needs is equal to the 38 total that he has to make. All right, let's look at number 2. DJ Tay wrote the equation below to solve X, the total number of minutes she spent making N cups of chili for the chili cook-off. All right, so pay close attention and notice that it's X equals 6N. X equals 6N. So what we're going to be doing here is we know that N is for the cups of chili, right? That's what we're going to be solving for, and it tells us that X is the total number. So let's pop that in. 102 equals 6N. And now that we've done that, we need to solve this as a one-step equation. First, circling our variable, looking and seeing what's happening to that variable. It's being multiplied by 6. So therefore, the inverse of multiplying by 6 would be to divide both sides by 6. These two 6's poof disappear because they turn into a 1, right? That invisible 1. And now we have on this side, we need to solve it. So over here is N equals, and 102 divided by 6 is 17. So how many cups of chili did she make? 17 cups. Number 3, what is the solution to X plus 1/2 equals 3/4? X plus 1/2 equals 3/4. And I'm trying to get this a little clearer for you guys, but it's kind of hard to see. I'm sorry. But all right, so I see that I have a one-step equation here. I'm going to circle my variable. What's happening to it is 1/2 is being added to it. So I'm going to subtract 1/2 from both sides. These 1/2s cancel out to 0. Leave me with X equals. So I have to do 3/4 minus 1/2 over here. And I have two different denominators. So I am going to set these up to have some equivalent fractions so that I can find the least common denominator. And I know with 2 and 4, the first number they both have in common for multiples will be 4. So that's the common denominator we're going to use. So I have to make sure this is equivalent. I'm going from 2 to 4 by multiplying by 2. So therefore in the numerator I need to take that 1 and multiply it by 2. And here I'm going from 4 to 4, no change. So from 4 to 4 is times 1. 3 times 1 is 3. So now instead of 3/4 minus 1/2, I have 3/4 minus the equivalent of 1/2, which is 2 over 4. So now that we have a common denominator, our denominator stays the same, and we say 3 minus 2 is 1. So X is equal to 1/4. All right, so number 4, there are X students in Mrs. Johnston's class, and 1/3 of them like to watch Cocomelon. And I don't know if I'm saying that right, but if 8 of the students like to watch Cocomelon, write an equation that can be used to find the number of students in the class. So all they want us to do is write an equation. So 1/3 of them like to watch Cocomelon, and I'm going to use a variable. I'm going to use a variable of X, and X is going to represent the students in the class. All right, X is going to represent the students in the class. So 1/3 of those students like to watch that show. And when they do, it's 8 of them. It equals 8. So that would be my equation. All right, number 5. Find the value of t in the equation. T divided by 12 equals 84. So sometimes, guys, it is helpful to rewrite it so that it's a little more clear for you, but it's still the same thing, right? That slash is our fraction bar. So this is a one-step equation. Circle our variable, see what's being done to it. It's being divided by 12. That means I'm going to multiply by 12 on both sides. These 12s here, poof, be gone. They turn into a 1, that invisible 1. So t is equal to 84 times 12, which is 1008. All right. Number 6, extra large rainbow popper fidgets cost $12.65 each. The equation 12.65x equals y represents the relationship between the number of people buying popper fidgets and the total cost of the popper fidgets. What quantity represents the dependent variable in the equation above? All right, so something to note. They want to know the dependent variable. So I already know that y is the dependent variable. All right, x is the independent, y is the dependent. And let's see, it says the equation 12.65x equals y represents the relationship between the number of people buying popper fidgets and the total cost of the popper fidgets. So our total cost, that's the y. So which quantity represents the dependent variable in the equation above? Y, the total cost. All right, let's look at number 7. Nick is selling tickets to the car wash to support his daughter's lacrosse team. Each ticket costs $10. If T represents the number of tickets he sells and C represents the total amount of money he collects, write an equation to model the amount of money he could raise. All right, so if I teach you, you know that one trick that I tell you to try to look out for, one thing to look out for is whenever they say the total amount of money, I know that it's going to be an equals, right? It equals a total, and it says C represents that. So whatever I'm doing is going to equal C. And that makes sense to us just intellectually because we know that when we are doing a math problem, it equals that total at the end. So there it is. So if he's selling $10 tickets and T represents the tickets, so however many tickets that he sells, it's 10 times those tickets is equal to C, the total cost. That's your equation. Let's turn it on the back. All right, Caroline used the equation y equals x plus 4 to represent that the number of dollars she earns, y, is always 4 more than the number of dollars she saves, x. Create a graph to represent 4 solutions to Caroline's equation. All right, so in order to do that, we are going to make a table, x and y, and we know that our y is going to equal this rule here, x plus 4. All right, so we're going to pull just 4 points, 1, 2, 3, 4, looking at our x axis, and we're going to pop this in, each x into our x plus 4. 1 plus 4 is 5, 2 plus 4 is 6, 3 plus 4 is 7, 4 plus 4 is 8, and now we have our coordinate pairs. So over to 1 and up to 5, over to 2 and up to 6, over to 3 and up to 7, and then over to 4 and up to 8. And now we have created a graph with the 4 solutions to Caroline's equation. All right. Number 9, Mr. Cannon kept track of the number of football games he watched over the winter break. The table below shows his results. Write an equation to represent the relationship between the number of days and the number of football games that Mr. Cannon watched. All right, so I see it's going from 1 to 2, 2 to 4, 3 to 6, 4 to 8, 5 to 10. Guys, I'm seeing it's taking that X and it's multiplying it by 2 in order to get my Y. Boom, there's my equation. And number 10, the graph shows Y, the cost of using a cell phone, for X, the number of minutes it was used. What is the independent variable and Y? All right, the independent variable. All right, so I know that the X-axis is the independent variable, so that means the minutes used per month. That's the independent variable. All right, and why is it the independent variable? Well, there are a couple things to consider here. For one, the cost depends on how many minutes that are used, right? So I know that the cost is the dependent variable. And I also have to consider that the minutes used per month, as these minutes increase, the cost is increasing. So that tells me that the cost depends on the minutes, because the cost only goes up when the minutes do. All right. So guys, that was our study guide. I hope this helped. You guys are going to do great.